You know, I mentioned to you about having a pen pal or someone to write a letter to or email or whatever to exchange rocks. We don't have to look at these real close, but it's where they're from is what's neat. This was given to me by a student who traveled to Europe, and he went to Switzerland. And these little rock pieces are from the Matterhorn. The Matterhorn, not the one in a little Disney place, but this is from the real Matterhorn. So I think it's kind of cute because these are rocks that are coming in. I got a rock that's coming in from Hawaii, another one. I jokingly to the parent, I said to the parent, I says, you know, when your son comes back from vacation, he's going to bring me the rock. Ask him to tell me or write down for me the latitude and longitude. Of course, that's a joke, you know, so I know exactly where the rock came from. You know, if you're an archaeologist, that's one who studies fossils and things like that, you have to know exact location. In fact, they always photograph the rock before they take it out of its location. And you have any idea what this is? Oh boy. Yeah, this is a prospector's hammer. That's solid iron or steel, whatever, all the way through it, and a little rubber handle so you don't hurt yourself. I mean, this hammer has been a lot of trips with me, and I've done a lot of chipping of rocks and breaking things loose. You can pick it loose, or you can slam it flat. If you're after something sort of delicate, then you want to pick it out. But that's a prospector's hammer, and it's solid steel, so it's made to last. Okay, the rocks. A family of rocks we need to look at. It's called igneous. Igneous means, and we mentioned on the first lesson, it had to do with heat, or rocks from a volcano. So igneous is the rock. So let's now take a look at this very primitive drawing here, just to get some little idea here. And what we're trying to do here is to show you that there are certain rocks that you need to look for to add to your collection. Now you can find them yourself. They might be in your own yard. In fact, some nurseries sell certain ones of these rocks. And the words are such things as granite, basalt, balm, that's a word, yeah, lava, pumice, and obsidian. Now, the words that are written, they're on the screen for you. They match the drawing on the right, which is a volcano. The top of the volcano, and then we come down to the center of the volcano, and then we have water. This represents water. This is all important to know. All right, let's take a look at each one of these rocks that are volcanic in nature. Now, the first one is simply the fact that it's going to be granite, and granite is the one in which, you remember before we talked about feldspar, or the glue? Well, okay, that's the rock we've seen before. That is what's inside a volcano. Before things get heated up, nasty, or whatever. Now, what do you think would happen to a rock inside a volcano look like that? Would you get this? This is what you call cooked. 8,000 degrees. You know, a volcano is as hot as the face of the sun. Not the interior of the sun, just the face of the sun. About 8,000 degrees temperature. That's Fahrenheit. And notice that there's a radical change in these rocks. The granite is just pulverized. Now, deep within the volcano itself, of course, it's called basalt. And there's a place that might be near you. It's called Devil's Tower. It's a huge rock formation that comes up. And I had a picture of it, but it's so teeny-weeny that it just didn't work right. It was like 30 miles away. But anyway, it was the center part, the throat of the volcano. That's all that's left. Everything else has been weathered away, you know, the winds and rains and all that. So if you see rocks going straight up in chunks, you're looking most likely at basalt. So you need one of those. Small, please, because those are quite heavy. The other rock that you saw just a minute ago, this black lava rock, when I went to pick that thing up, I'm telling you, I put my hand on it and I went, ah! It burnt my hand. Well, not exactly, but I did take my hand away real quick. Picked up a handkerchief and I covered the rock and threw it in the trunk of my father-in-law's car. Why was the rock hot? Had I just arrived after the volcano had thrown up, you know, erupted? No. We were in the middle of the Sonoran Desert in the country of Mexico, and the temperature was 115 degrees. And we knew that because halfway through the desert area of the Sonoran Desert, we came upon a military outpost, a little guard with this building, and they had a thermometer there, and it said 115 degrees. So we were right near where we wanted to go. We didn't go to the big cities. We went to places where geological formations were. And I wanted to get some rocks from the volcano in Mexico, in the Sonoran Desert. So that's why that thing was so hot. All right, so here you have a volcano. It's erupting. And comes the lava. That's what that rock is. It's lava. Now, some volcanoes are so forceful when they erupt that you can get a rock like this little guy here. Let me just put it right next to the black one. This is called volcanic bomb. Now, this is what really tore up the city of Pompeii, some people believe. Volcanic bomb. The lava, when it came out of the volcano, shot so high up into the atmosphere, the lava actually cooled off. And when it came down, it formed little balls. I usually joke around saying this is somebody's meatball and spaghetti, you know. It's pretty nasty, pretty solid. But that came down in a cooled off formation. And of course, this can kill people and destroy buildings. Volcanic bomb. Well, we were up around Yellowstone National Park, and I mentioned that in one of the lessons too. That's a real pretty place up there. Not quite as pretty as you guys that live out there in Seattle. Mount Rainier, and that was spectacular. And of course, then again, you got the Canadian Rockies, and it's just one thing after another is most spectacular. Okay, so we're going down to the lake at Yellowstone National Park, and saw plenty of bears, but nobody named Yogi. And what we're looking for is that the beach was jet black, and I mentioned that to you. Now, the beach was made up of this material here. When lava hits the water, it turns to a natural glass. And volcanic glass has the name obsidian. Now, what I want you to notice on this obsidian rock is like those little swirls. See those swirls there? Concentric circles? That's how you identify obsidian, by cleavage. Remember we talked about that word, how the rock breaks. So that's lava that has hit the water and became glass. All right? But as we approach the beach, we found, let me see, we found this one. Let's take a look at that one. Here we have, look at the pebbles in here. It looks like the conglomerate we had some time ago, but no. This is volcanic lava with little pebbles stuck in it. So this is lava that had almost cooled off, picked up the gravel along the way, and the gravel was not cooked, and we ended up with a neat rock like that. And then we got down to the water's edge, the black beach of obsidian, all ground up like powder. It was an obsidian volcanic glass beach. And yes, you have to be careful with your feet. Now, this is mainly sand with little speckles and little spots of obsidian. This was down in the bottom of the lake. In other words, it is waded so far in, not very far. It's kind of cold. And I just reached up and pulled this rock off the bottom. And you can see that it's all of these little black spots were the grains that were in it. Now we have this one. I was the top of Mount Rainier with the family. And there's a dish of water. You know what this is, don't you? You know what we're up to here? We're going down the trail, and we look into this creek. Maybe you say crick. And this was floating down the creek. And, of course, you might think, well, something's not right for something to be floating. So I picked it out of the water, and what we found is called pumice. Pumice is lava rock that floats. Isn't that neat? Now, if I let this sit there for a long time, it will soak in enough water and it'll slowly sink. But it does quite well for itself. So if you're up into the mountain somewhere areas and you're looking for any, rocks, of course. If you see little rocks floating down water, then you got a good chance you're looking at some pumice. So those rocks that float. Now, pumice happens to be, see, the best way to explain it would be take soda. You know how soda gets the foam on it if you shake the can or the bottle? Okay? Pumice, let's say, is like the foam. The lava comes down the side of the mountain, boiling and bubbling, and at certain times or another, you can get a foam on the top, and that cools off, and that becomes the pumice. Because you see, look at this lava.